The topic I'm going to introduce you next is the variability of averages and proportion. To discuss the variability of averages and proportion, let me introduce you a box model first. Making a box model to represent a given random experiment or a study. When we make a box model, those information should be well specified. Okay? First one, we need to tell people what numbers go into the box. And actually, there are two different boxes. First one is called a 0-1 box. And second one is called a non-0-1 box. A 0-1 box, only 0 and 1 go into the box. A non-0-1 box is any box that is not a 0-1 box. Okay? In my lecture, sometimes I will say 0-1 box, a count box. And a non-0-1 box, I call it what? Sum box. Count box, sum box. Okay? Now, second information need to be well specified. Is how many each count. And third, how many draws. The number of draws is used to specify the sample size. If I make 2 draws, that means the sample size is 2. 4. We need to tell people the draws are made with replacement, the abbreviation WR, or without replacement. The abbreviation is W/OR. Okay? With replacement or without replacement. Now, with replacement, the draws are independent. Without replacement, the draws are what? Are dependent, not independent. Okay? When we make draws without replacement, there are some dependency among those draws. Okay? Now, let's look at a very concrete example. Let's look at a very concrete example. Example 1. Example 1. Flip a failed coin thrice. When we flip a failed coin 3 times, and we are interested in the number of heads resulting, I use the variable x to denote what? The number of heads resulting. Okay? For example, if I make 3 draws, what do I find? Well, I find first draw is a head, second draw is a tail, the third draw is what? A head again. And I use xk to denote the outcome of each time, each draw, outcome of each one, each flip. Now, if the case flip is a head, when I make the case flip, I see a head. I count 1. 1 means what? 1 head. If I see a tail, otherwise, I count what? 0. 0 means what? 0 means 0 heads. Okay? No heads. 1 head and no heads. Okay? 1 and 0. So, x is a number of heads resulting, and this is also sometimes called what? The sample count. And this is equal to x1 plus x2 plus x3. x1, we see a head, it's 1. x2, we see a tail, it's a 0. x3, we see a head again, it's 1. We count 1 head, 0 head, 1 head. So when I add x1, x2, x3 up, they add up to what? 2. So how many heads I see? I see 2 heads. Okay? Now, how can I create the box model? Okay, how I create the box model to specify this random experiment. Look at here. A box model for the random experiment. I call random experiment 1. First one, what number go into the box? You see 1 and 0. And what are the ones? One are used to use what? The ones are used to specify the heads. 0 used to specify tails. When I see a head, I count 1 head. When I see a tail, I count what? 0 heads. Okay? Now, what number go into the box? 1 and 0. Okay, so, and since I want to specify, it's a fair coin. A fair coin means the chance I get a head is what? 50%. The chance I get a tail is also 50%. I can just use 1 to 1. Okay, so chance I get what? Number 1 ticket is 50%. The chance I get number 0 ticket is also what? 50%. Now, another way to specify it's a fair coin. I can use 1, 1, or I can use what? P and 1 minus P. Here, P is a probability of getting heads, okay, in a single flip. P in this case is 50%. So I can use 50% or 1 minus 50%. Alternatively, I can use what? 1, 1. They are all used to specify the given coin is a fair coin. And n equal to 3, I make 3 draws. Okay, I make 3 draws. N is a sample size. And this is what? With replacement. If this is without replacement, after I make 2 draws, the box become what? Empty. Okay? So this is what? With replacement. With replacement. Okay? Now, let's look at those what? Comments. This box, because only 0 and 1 go into the box, okay? So this is a 0, 1 box. Or I sometimes say what? This is a count box. Because we try to count something. That's why I say count box. In this example, what do we want to count? We want to count how many heads we see. Second comment. The sample count over the sample size is sample count divided by sample size. This is what we call the sample percentage. In our example, x2, we flip what? A fair coin 3 times and we see what? 2 heads. So x is 2. Okay? Sample count is 2 heads. And n is 3. Sample size is 3. So x over n is 2 over 3. And that is 66.7%. The 66.7% is a sample percentage of getting heads. Some books use what? P hat to denote x over n. Because we use P hat, try to use P hat to estimate what? P. In most real life application, we use what? P hat to estimate P. Okay? Now, comment D. P is equal to average of what? Box. What box? Count box. In our example, it's a fair coin, right? So it's 1 plus what? Sorry, this is not 1. This one should be what? Should be 0. 1 plus 0 divided by 2, okay, is equal to 50%. Please change this one to what? To 0. Look at the box. Look at the box, okay? Look at our box here. You see 1, you see 0. How many 1? 1, 1. How many 0? 1, 0. So it's 1 plus 0 divided by 2. So the average of the box is what? Is 50%. Okay? So this place should be changed to 0. Okay? Should be changed to 0.